does too, so you're actually doing them a service, they don't have to ask it. So what this talks about. So it's the benefits of bringing a DevOps mindset to digital forensics. And what I mean when I say a DevOps mindset is both the obsession with automation and the mindset that everyone on the team, no matter where they are, if you've got a dispersed team, the mindset that everyone on the team should at any point in time be able to see what's going on with the processing. We'll also talk about how to automate that evidence processing using Jenkins. The other thing that we'll do is look at the ELK stack. Anyone in here familiar with ELK, ELK, Elasticsearch, Logstash, Kibana? Anyone actually using it in anger? Yep, still a few. Cool. And finally, I'll talk about Forensicator Fate, which is a lightweight DFIR manager which abstracts away even the complexities of Jenkins. So what this talk is not about. Nintendo or VB forensics, that's Visual Basic, not the second-rate Aussie beer. And it's not about black box automation, right? It's very definitely not about you press the button and the magic tool spits out the results and you don't know how those results came to be, they just are because the magic tool says so. Okay, what's DevOps? This is the 10,000-foot view of DevOps because DevOps is, subject to as many wars about what it is and what it's not and who is and isn't really practicing DevOps and all that sort of thing. But anyway, developers develop with operations in mind, and operations use the same tools and the same techniques as developers do. It can't be that simple. It's not. So there's heaps of information on the web, on Twitter, on IRC. Yes, it does exist for something other than command and control channels for bots about DevOps. And the two places to start are the links that I've got up there. The second link actually has a really jumping off resource list to a whole lot of other resources about what DevOps is and isn't. So, why should we do this? I'm arguing that we need to move from being artisans to engineers. We need to be able to specialise, and so we need to be able to collaborate. So, artisan versus engineer. Well, what's the difference? Well, the definition of an artisan is a worker in a skilled trade, especially one that involves making things by hand. An engineer, on the other hand, is a person trained and skilled in the design, construction and use of engines or machines. So you can get that they're both skilled, right? The difference is the engineering approach scales, right? And with what we're dealing with, with what, we heard in the keynote, right? The scale of some of these attacks, you can't afford laborious processes. One point I want to make before I move on, I'm not saying don't be an artisan, right? I'm not saying that at all. What I'm saying is don't be an artisan when what's wanted and needed is an engineer. So, why automate? Couple of reasons. Not everyone's as smart as you are. Obviously, I'm not as smart at 4:30 a.m. as I am at 10 a.m. Sometimes I am if I'm having a really bad day or I had a really good night. I'm not as smart when someone's yelling at me while I try and complete a complex procedure. If you've got somebody standing over your shoulder, we need this now, we need to know. And the fourth reason is quite simply, people make mistakes. With the best will in the world, with the best intention, with the best training, people, especially under pressure, make mistakes. So the following quote is actually from a book called The Checklist Manifesto, How to Get Things Right, by Atul Gawande. Now, This guy's actually a surgeon who took on, he's a both general and endocrine surgeon, who took on looking at how they could actually minimize casualty rates and how they could actually improve the care outcomes in public hospitals. And what he said was, under conditions of complexity, not only are checklists a help, they are required for success. There must always be room for judgment, but judgment aided and even enhanced by procedure. So it comes back to what I was saying before, right? It's not about black box automation. It's not about, no exercise of judgment. No, it's about empowering your judgment. It's about doing the grunt work so that you can then do the thinking. So you've got time to do the thinking so that you're clear that nothing got missed. So yeah, basically if you haven't heard of a tool go on or you haven't heard of the checklist manifesto, I recommend you do yourself a favour and check it out. And just in case you were wondering, you probably weren't yet because we haven't really talked about it, the FATE in Forensicator, FATE's an acronym and actually stands for from artisan to engineer. Before I move on, is everybody, presumably most people in here are familiar with Forensicator Pro, the 2007 April Fool's Day joke about how, there was going to be no need for the human touch in forensics because basically there was going to be a button and the button would be the find evidence button and it would just spit out perfect reports all the time, no judgment required. So this is aiming at that bar. It's an April Fool's Day joke, and at the same time there's a lot we can do to move in that direction. So the moving parts. Right, we start with the SIFT workstation, which is the basis, the toolkit, and the essential part of the solution. The rest you could use other tools, right? You can use scripting, you can use there are different continuous integration servers, you can use different databases. You don't even have to use Forensicator FATE. All that does is abstracts away even the Jenkins complexity. I'm not going to bother reading you out the URLs for all of this. They're actually in the slide notes, and you can get them when you've got the presentation. I did want to cover off, though, what we've done with ELK is use the Forensics 572 distribution that Phil Hagen did, basically for two reasons. One is for compatibility, because if you've got a tool set that does what you want and it's what other people are using, why not use it? And then the other one is it also uses, in the distribution, he's also included Explico, so you can actually look at your network traffic. So that's a good one as well. So who here has actually heard of or is familiar with Jenkins at all? Okay, so we got 3 or 4 tops. Great. So this is an opportunity for the rest of you. So what Jenkins is a continuous integration server that, along with the plugins that we actually load when we're installing the solution, lets you, one, automate the processes, but two, as importantly or more importantly, actually monitor the status of those processes so that you can see at any time where things are at. Let's talk resources. Everyone knows more resources are better, right? More RAM, faster disk, gimme, gimme, gimme. There was a great quote on Twitter just a couple of days back, actually, by John Stewart, CodeSlack, saying, if I have a speciality, it's forensics performance processing. So if it's instant, let me assure you, it's not forensics. But the important point here is this solution doesn't actually add a lot in terms of overhead to the tools that you're using anyway, if you're using the SIFT. So you can actually do real work with 2 VMs, right? One for your ELK server and one for your SIFT. The little note down the bottom there, I highly, highly, highly recommend SSD. In the absence of that fiber-attached SAN, just for the speed of getting work done, SSD all the way. So a couple of other points. If you start using the SIFT in a collaborative environment, you run into issues around the fact that it actually uses Samba and so uses Netbios to actually share the data. Has anyone used the SIFT to actually, use those shares, the cases and mounts share? You notice it's Netbios, right? So that means obviously you've got to open up those ports on a firewall if you've got firewalls in between the cooperating ones. I've got all the finer detail in the notes here, but basically you've got all your Netbios ports to worry about. You've potentially got NATing to worry about. The other interesting point is that because SMB uses name broadcasts, what you actually get is if you name your workstations SIFT Workstation 1, SIFT Workstation 2, those names are actually too long for Netbios. They're the same name, so you actually run into problems. So, short version, don't name your workstation SIFT Workstation 1, SIFT Workstation 2. It will end badly for you. Okay, so putting the pieces together. We start off with the SIFT workstation in the ELK stack, and then adding everything is simply a case of cloning the GitHub repository for the project, so the URL's up on the slide there, and then running the bundled installer script. Right? It takes about 15 minutes, which, let's face it, that's not too bad. And you have to hit the enter key on a couple of occasions when it prompts you for a default, and also tell the installer where to find ELK because that goes into the configuration database. It just moved in, has it? It wasn't by default still. They were working on adding it, like it was coming. Okay. If it's got, I know it was coming. I didn't know it. Like in version 3, the downloadable VM, it wasn't there. But if it is, cool. Yeah, certainly if you use the Bootstrap script and you were using a recent version, chances are it's there. Because I know Rob was actually saying, yeah, we should add ELK into the SIFT. It's that trade-off between you have a heavier SIFT, but everything's in one place. So, yeah, thanks for that. I'll actually have to have a look at that because I didn't think it had come down the pipe yet. So the script we ran installed more network shares, right, so that you can actually start breaking up who gets to see what, who works with what. It installed Jenkins, and it installed a library of jobs for the evidence processing, and it installed Forensicator Fate, which is the abstraction layer on top of Jenkins. So, yeah, anyone who tells you a problem shared is a problem halved has a problem. In addition to the standard SIFT shares, we add /reverse, /IOC, /whitelist, /blacklist, and /artifacts. So /reverse is where we dump stuff for malware analysis so that the reverse engineers can easily access them. IOC, as we uncover new evidence, we might want to generate indicators of compromise. So for example, if we've got other colleagues who are using Mandiant Redline, for example, or anything else that actually is willing to consume IOCs, you can actually have those available for them to use. /whitelist is where we place any known good hashes. So for example, if we've got the NSRL and we're using that to speed up processing, that's where we'd put that. Blacklist, conversely, is our known bad hashes, and artifacts is where the processed output of the case actually goes. One other point about the known good hashes is, and again, I've got a URL in the notes for you, but if you've seen the Sniper Forensics Toolkit approach to managing your in-house hash whitelists, that can also go there as well. So, We've installed the Jenkins server, but in addition to that, we've installed some plugins that let us actually build job sequences and let us actually have dependencies between those without hard coding things into the jobs. So for anyone who's actually, the 3 or 4 of you that have actually used Jenkins, we're using parameterized trigger and we're using conditional build step and its dependencies. Just go back. And then what we do is the Jenkins jobs are essentially split into 4 categories. There's the file system analysis tasks, the memory analysis tasks, find evidence, and the helper tasks. Now, the important point about this is it's an extensible process. It's not, these are the Jenkins jobs you get, don't touch them or you'll break stuff. No, no. If you've got tools and processes that are, you know, in-house IP or classified or whatever, right, automate yourself. Not a problem. If, on the other hand, you do want your tools and or processes in the public domain, you know, if it's stuff you can and want to share, then you can either add it yourself and request a GitHub pull, or you can just ping me either on Twitter or, you know, however, and I'll add them, right? We'll talk about later on requesting enhancements and reporting issues. Okay, this is where I regret the fact that I didn't get a chance to see these screenshots before we had the talk. Those of you know, down towards the front, congratulations. Those of you down towards the back, commiserations. But basically, I'm going to go through stuff anyway, okay? So the, not a pointer. The FAR category with the S, that's the status category. It tells you the last state of that job. In other words, the last time that job ran, was it successful or did it fail? Red obviously is failure. Blue, for whatever reason, hey, maybe it's just because, hey, it's cool, is the job succeeded. So the next category, or the next column, is the weather column. What that actually gives you is a visual indicator of how many of the last 5 runs of that job failed, right? So you can see, for example, carving, I usually, when I'm kicking it off by hand, I forget to clean up my mess, so the job fails, right? What else do I want to say about that? Oh, and then the jobs there that we've got are bulk extracted disk, carving, FS timeline, so file system timeline, so the lightweight timeline, sorter, and super timeline. So the bulk extractor disk simply, you know, runs bulk extractor with the provided keywords list. Carving does the unallocated storage carving, so runs block ls, then determines the cluster size with fsstat, and then runs foremost with those parameters to actually carve out your deleted files. So even there, you're starting to save a little bit of time and a little bit of thought and a little bit of having to, you know, look at the results of this and plug them in here. And the FS timeline is the file system timeline with FLS and MAC time, obviously. And the super timeline actually uses Plazo to generate the full-on timeline, which then, if we're doing the wrapped up job, the find windows evidence job, it actually ends up then being transferred into the ELK distribution that we were talking about. By default, it creates the spreadsheet that if you've done, you know, 508, you're familiar with anyway, and the colorized timeline in Excel that you can actually look at. So that's the basis for that. Over on the far right-hand side, you see that weird little clock thing with an arrow. That's schedule this job now. Okay, memory analysis tasks. Similarly, there's bulk extractor memory, and we've got 9 volatility tasks. It's not as bad as it looks. I mean, actually there's 10. There's one overall volatility analysis task. There's step 0 there actually does if you don't provide the profile, it'll actually run image info against the profile, determine what the best guess is, and then provide that to the further steps of the volatility processing. The next 1 to 6 are the standard, 6 steps. So you've got identifying rogue processes, you've got analysing DLLs and also handles, you've got reviewing network artifacts. Step 4 is looking for evidence of code injection. Step 5 is checking for signs of a rootkit. Step 6 is dumping the suspicious processes and drivers. Now, at this stage, what it actually does is it simply dumps all processes and drivers and allows you to determine which ones you're interested in. Because it's doing it automatically for you, I thought it was probably better to dump them all and then allow you to use your judgment about which ones you're interested in based on the results of the other jobs, than make an assertion that, hey, these are the ones you're interested in, miss something important for you. That's one of the ones that there's actually going to be some further work in terms of actually doing more of this, for you in terms of analysing the results of the other jobs. And so, instead of you spitting out everything, it spits out ones you're more likely to be interested in and flags the others. Yep, they are. There's a couple of things. One is each of them's actually documented in the speaker, like when they send out the presentation, they're each documented there. But also, if you actually click on one of those, the jobs actually have descriptions, like it says a short, this is what this one does. And then the other thing is the volatility job there is actually, if you want to do memory processing, it will just run the jobs for you in order. So if you want to just point it at an image, you point it at an image, it just runs the deal. Exactly. If you just want to do one versus do the whole thing, then yeah, you click on the individual jobs, you can see the descriptions, you can fire off individual jobs, and that's where they are scheduling. It's a button, believe it or not. It doesn't work for me, but anyway. And then steps 7 and 8 are 2 extra ones beyond the standard 6 step. Step 7 is registry analysis, basically does the user assist. And step 8 is actually memory timelining, so that you can actually cross-reference the results of that with your super timeline. Then we've got our find Windows evidence job, which essentially, if you've given it a disk image, it will run only the disk image processing tasks. If you've given it a memory image, it'll run only the memory image processing tasks. If you've given it both, it's obviously going to do both. So it's kind of the one click, do my processing for me. The helper tasks are IOC and NSRL. Basically, it's about putting stuff where you want it. The NSRL one will also actually, once it unzips the NSRL zip for you, it'll also go off and generate the indices that are used by hfind. By sorter, the hfind indices. Okay, and a fair few of you have used ELK. For those of you who haven't, this is what an ELK visualization of the timeline drilled down to a particular time range, and then searching for Vibranium, because I was doing it against the 508 images at the time. And you can see you've got your hits there on your histogram. Down here, this is source distribution, right? So you can see each type of event. It's also as a table in the parsers. You can see the counts, right? And it's also the generated hosts. And then underneath, what you've got is you've got the individual events, in a timeline, and you can actually click on any of those events, and it spits out the whole details of the record. you can have multiple records expanded at any one time and just close them up again. Okay, so what we've done with Jenkins is we've automated that evidence processing step, right? But can we take that even further, right? Because you've still got, with the Jenkins setup, you've still got jobs for specific things, and if you're doing it that way, you have to think about, well, what do I want to do now? And I'll fire off that job, and I'll give that job the parameters it needs to do what it needs to do. Right? So the question I asked was, could a putative neophyte DFIR engineer create new cases and then just hit the find evidence button? Better still, could an examiner who's actually collected the evidence start the process of processing that evidence so the analyst can then come on to the case and start analysing it? Short answer is yes. This is the Forensicator Fate GUI. You'll notice that my day job is not user experience designer. But on the plus side, hey, there's a find evidence button. Dropping the mic, walking away. Woohoo! So the one thing about this is actually starting to process a case is as simple as you create a case and enter the details, and then you really do click that find evidence button. It'll run, essentially at the moment, it's limited to Windows cases. I've used the underlying Jenkins jobs for Linux server investigations, but I haven't put together the find Linux evidence. That's coming quite soon. When you click the create a case button, you can see required fields are a case name, at least one image file, and a time zone. Okay, our next two tabs are the indicators of compromise and reverse engineering tabs. The thing about these is that they're for assisted views of the contents of those shares. So for example, if you're looking at artifacts and you've done the evidence processing, you can browse around until you hit the sorter output and just dive into the file system tree and look at what's there, right? IOCs aren't quite that useful because I don't know about you, but the UUID of an IOC doesn't tell me very much that's useful about the IOC, right? What's the purpose of the IOC? So the default view actually gives you the IOC, the size, the hash, and the short description. If you mouse over, because IOCs tend to have quite wordy long descriptions, if you mouse over a particular IOC, it'll give you a tooltip with the long description. But by default, it simply shows the short description. And then this is the contents of /reverse. You'll notice that file, unlike the IOCs, for example, which you can actually download the IOCs through the Forensicator Fate interface if you want to. Unlike that, you can't click on the contents of /reverse and accidentally download something. Mistakes do tend to happen that way. Because usually what we actually are interested in is that hash. If we want to query, file advisor, for example, fileadvisor.bit9.com or VirusTotal, searching those by hash doesn't give away our knowledge of the attacker's TTPs, unlike uploading a discovered binary. So, does anyone not understand how uploading a discovered binary actually is there anyone for whom that's news? Because I'm quite happy to say why that's, a bad idea, but if everybody in the room understands totally why that's a bad idea, then, I'm not going to belabor the point. Anyone not understand? Should I cover it anyway? I'll cover it anyway. I've got a hand. Okay, so consider that if an attacker's using an exploit to attack you that hasn't previously been seen in the wild, all they need to do is poll VirusTotal for the hash. As soon as you upload that binary to VirusTotal, they're going to get a hit on that hash poll. So they know that you found what they're using on your network. If, on the other hand, you're simply uploading hashes, they don't get that. Now, that leaves out one category of attacker, obviously. Anybody who can see everything going across the network is going to see those hash queries against VirusTotal anyway, but we don't know any attackers like that. Sorry, how what? That's right. And it's a trade-off, right?
Which means that then other people doing an investigation are going to get no hits when they upload.
Yep, and it is a trade-off, right?
If you come back to the previous report, there has to be some way of sharing information.
Yep, totally agree. And, you know, it comes down to, I think, at some point as post-work, you want to upload these things to VirusTotal.
So once you finish the case, upload it.
Yeah. Well, once you've finished with the ramifications of the case, upload it. Right? Because that way you're sharing, VirusTotal is still useful for everyone, and you're not telegraphing your knowledge of their TTPs while it could still make a difference.
Yeah, I'm just wanting to make that point.
Yeah, it's a great point. It's a great point, because otherwise, essentially, you make that resource useless. Sure. Yep. And, you know, I guess one of the things that it comes down to is, are you having serious problems with commodity malware? You know, maybe if you're having serious problems with commodity malware, you've got some other work to do. True. Hey, and as the intro slide said, you know, I work for Cisco now, and they do a lot with uploading the malware and processing that in the cloud and having the hashes and, you know. Okay, so how did the binary get in the RE share was quite a reasonable question. Short answer was I put it there. Slightly longer answer was I put it there after seeing it was interesting based on the results of some of the jobs run. Right, so some of the volatility processing indicated that that binary was interesting, so I moved it into the reverse share so that the malware analyst could actually have a look and actually reverse engineer it and so on and so forth. It was actually interesting from memory, but I got the image from disk and move the file into that share. The volatility jobs also do dump the process maps, so essentially you have stuff that's still worth actually processing, you know, with a scanner, for example, or doing binary analysis on. So one of the next steps in the further automation phase is we're actually going to look at attempting to pre-classify binaries or, you know, document types that might as well be binaries as interesting. IOC scanning is actually coming in the release that I was hoping to have done today, but it'll come up sometime this week on GitHub. Show of hands, who's familiar with IOC scan? Open IOC scan, sorry. Yep, so a few people. Open IOC scan is actually a really interesting volatility plugin. It was done for, I think it was the 2013 volatility plugin comp. Was one of the winners of that. It you know, essentially, as it says, it basically runs a series of IOCs that you provide against your memory images so that, you know, you can flag any hits. So the other thing that's also coming, but a bit further down the track, is IOC scanning for Plazo against the disks. Right? That's going to take a little bit longer because unlike where the OpenIOC scan volatility plugin already existed and it's simply a case of doing the integration work, there is no Plazo support for IOCs, and the developers seem to want to roll their own. I kind of rank that somewhere between never get involved in a land war in Asia and never going against a Sicilian when death is on the line. You know, so somewhere in the middle there's roll your own support for something that's like IOCs but don't support IOCs. You can do either. What the Find Windows Evidence job does is it actually, if you've only got a memory image, it will only run the memory image processing. If you've only got a disk image, it will only run the disk image processing. You know, and sometimes that happens. Let's face it. If you've, for example, had a VM running in Amazon and you have reason to suspect that that's been compromised, right, you may only have the disk image available. You may not have a memory image. Okay, so I already telegraphed this. Coming for the Summit release this week, there's the OpenIOC scan support. There's also DFIR in the cloud. Now, what I'm not talking about is performing DFIR on your AWS images. What I'm talking about is the ability to perform DFIR in a VPC running on AWS. The interesting thing about that is that what actually happens is that your initial setup actually runs a Jenkins job that then creates the VPC. You know, you have to give it the appropriate privileges. It creates the VPC and then actually spins up inside that VPC a Jenkins server, which in turn has the same job that could potentially create a VP. Anyway, that's why I called it the Inception Jenkins job. After that, we've got more automation, like actually empowering you further in terms of the evidence processing. Colorization, the packets never lie, and compartmentalization. So automation of the investigation beyond the evidence processing phase. So one of the things that I'm looking at is that an analyst can say, this is interesting, create me an IOC. You know, for whatever values of interesting and whatever you think the key indicators are, and it'll actually use the Python. Who's familiar with PyIOC? Yep. So basically there's full class OpenIOC 1.1 support for IOCs available in Python in an open source project, kind of handy. So obviously, Mac forensics, Linux forensics, the Linux one is actually a lot closer at the moment because most of the jobs currently, just due to the nature of the tools in the SIFT, already fully support, you know, Linux file systems, Linux memory images, they're first-class citizens. So that's just a question of, you know, when do I do it? I'll probably try and get that one out with this week's release, with the Summit release. Network forensics, one, find evidence to rule them all, because obviously once we start actually having different jobs, then, you know, you still have to select which job or why. You know, the system's quite capable of looking at the memory image and going, you know what, it's a Linux memory image, you know what, we're going to do the Linux processing against it. The caveat there is that things can look similar. Like, for example, if you've got SmartOS. Does anybody SmartOS? basically a Solaris derivative, but it's got a Linux binary call interface. It's the guys from Giant, really cluey guys like Brian Cantrell. So basically what it comes down to is just making sure that, you know, it's not fooled by what appears to be Linux structures, but was in reality a Linux container running under SmartOS. And binary analysis, including AV scanning, I mean, you know, it's one of those things, right? If you're being attacked with anything interesting, AV scanning is not going to do anything for you. On the other hand, not everything's interesting. You know, we still need to do the work. The colour is simply the case of, as you saw when we had the elk. Sorry, David.
Before you go on, how easy is it for other people to start working on solutions like that? So I have a good example of how easy is it for people to start working?
Really easy. Basically, the bits and pieces that actually run the tools are essentially shell scripts inside of this Jenkins wrapper that takes care of the environment variables that they get and that sort of thing. All Jenkins is really doing is sharing the status information and allowing you to orchestrate the tasks, right?
My job will be to write those shell script tasks that will call out to the other tools and pull them.
Yep. And, you know, that's it. One point I made here is, I really, like, compared to Excel, it's a no-brainer, right? ELK is a far superior method of storing large volumes of data, right? But at the same time, if you've used the super timeline, you know, human beings process color really well, right? Both as predator and as prey, the ability to process color is handy. So we process color really well. So the colorized view of the timeline, I think, is actually superior to what we get by default in the Kibana dash. So I'm actually clear that that's something that is going to be added. The other thing that I'm also going to support, which I didn't actually have up on here, is has anyone used TimeSketch? Yeah, David and a couple of others. Yep. So TimeSketch is awesome, but they have a totally different approach to colorizing. Like, their approach is you can look at a multi-host timeline, so they use color for indicating which host you're talking about. Doesn't play really well with Rob's approach to colorizing the timeline. So we're in discussions about that, and I've got to come up with, you know, what seems like an effective approach, but if I do, he's quite willing to implement that, so that's kind of cool. I talked about that, packets. One thing I didn't mention there is, one of the things that I'm looking at is taking the IDS alerts, putting those in ELK and being able to use those, if nothing else, being able to use those as pivot points, so you can see interesting points at which it's time to hone in on the timeline. Compartmentalization. So, like the SIFT, what I've gone and produced makes certain assumptions about the environment and about who you can trust in the environment and the degree to which you can trust them. You know, as we allow for teams of collaborating experts, those assumptions don't hold, or don't always hold. Right? As I've said on the slide, an expert consulted for their expertise on one case may not have clearance to view another case's details, and likewise, an expert consulted for their particular expertise may not have the clearance to view all the details, even of the case for which they're consulted. So, requesting features and reporting bugs. There are no bugs. No bugs. There are lots of bugs. What I'm trying to do with the issues page is I'm actually tracking issues even in the upstream projects so that it doesn't get lost. So, for example, anybody run into the ext4 file system loop issue with Plazo at all? Anybody do any Linux processing? No? You're so lucky. So yeah, the issues page on GitHub is where that's at. You can tweet at me to tell me about stuff. I don't mind getting tweets to say, hey, there's a bug in blah, blah, blah. Cool. I'll just, enter the issue for you. Or you can tweet at the project. I set up for the DFIR Summit, I finally set up the project's Twitter account. Well, no. Go away. Now I have to work out how to select. That actually is me, and that's a typo, and that's kind of silly. Thanks for that. Yeah, I think there's a 3 in there. That's the wrong. I can't believe I got my own Twitter handle wrong. How bad is that? Thanks for that, David. Who gets a Twitter handle wrong, really? Okay, so tracking progress. Likewise, you can watch the project on GitHub. Anybody who's used GitHub before, it's basically as simple as clicking on the little eye icon and you can watch the project and you'll get status updates when stuff gets checked in and that sort of thing. It's probably not that effective because, as it's an active development project, and hopefully after today even more active because all of you are going to go, yeah, I want to use this, you probably don't want to know when we're refactoring stuff. So I'd recommend actually following the project on Twitter with that actually correct handle, or you can follow me. This is going to be one of those rare occasions when somebody says, I actually don't recommend following me because in addition to computer security, I tend to retweet a lot of stuff on human rights and social justice issues and that sort of thing. So unless you're really big on that sort of thing, don't follow me, follow the project. If, on the other hand, you're really big on that sort of thing, feel free to follow me. And then just finally, I wanted to acknowledge some people. Obviously, Rob Lee. 4508 was actually really fun, but more importantly, the SIFT workstation has actually been really useful, right? Also, Ovi Carroll and Brett Padres, they're the ones who, Forensicator Pro was an April Fool's joke, right? But it's also given me a bar to try and clear with this project. Bianca from PwC did a lot of the over and over beta testing of the install scripts and the reading the white paper and all that sort of thing. Wow, I'm really losing with the projector today. It's a win. Just as well I'd finished the slides. If I'd done that during the presentation, that would have gotten ugly. And Chris Walker was actually the reviewer for the GCFA paper on that. And the great thing about Chris was, without him, the project would have existed anyway, but it wouldn't have been as well documented. And then you guys, because, hey, you could have been at one of 2 talks, and Sarah Edwards' talk looked pretty good. So thanks. That's it. Any more questions? Anything? Yep. Mainly at the moment, it's the Plazo data. I'm actually looking at what makes sense to dump into ELK. There's kind of 2 things, right? One is the more we push into ELK, the more useful queries you can do against it. So from that point of view, I'm kind of going, well, really, I should probably dump pretty much everything in ELK. The other one is stuff that's kind of metadata-y, right? On the one hand, you could make an argument for it doesn't actually need to go into ELK as long as it's available and queryable and like usable. So that's kind of the, I'm open to, if people are using it and go, hey, it'd be really useful if this data was in ELK, sure, I'll shove it in ELK. It's not hard to get data into there. So that's kind of where that's at. Yeah, it'll be in the presentation that they're mailing out, but let me just skip through. There we go. Any more questions? I think we're good. Thanks, David.